In today's lesson, we're going to be looking at TEKS 5.3c, and that deals with dividing whole numbers. My content objective is I can accurately use the standard algorithm for division. Language objective, I can explain my process for using the standard algorithm for division. Essential question, what is another way to solve the problem? And I can answer that with the sentence stem. Another way I can solve the problem is, and then fill in your information. All right, so we can look at division as an extension of what we know about multiplication. So if I had some number times 3 is 12, one thing that I could do is I could just guess and check. I could say, well, 1 times 3 is, nope, that's not it. 2 times 3, nope, that's not it. 3 times 3, no, that's not it, and just try to get closer. And I might think, oh, well, it needs to be higher, so 5 times 3 is, and then count that out, and that's 15, so that's too much, and just kind of zero in on what my answer is. Another way that we could look at that is we could look at it with a fact family by using the inverse or opposite operation. So I could say 12 divided by, so instead of multiply, it's divide, so 12 divided by 3, and that's going to give me my answer. So instead of multiplication being groups of, some number groups of 3 is 12, what I could say is 12, my total amount, how many groups of 3 can I make with my 12? So if I have 12 total objects, how many groups of 3 can I make? And then that will give me my answer. So my 12 objects, I need to make groups of 3. So 1, 2, 3, there's one group of 3. 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 1, 2, 3, 4 groups of 3. And so my answer, of course, would then be 4, or 4 groups of, right? Groups of 3 is 12. So I can look at division as the inverse or the opposite of multiplication. All right, so far we haven't seen anything new. But let's keep going, and let's just continue connecting what we already know to what we need to know. So if I had the problem of 378 divided by 9. And again, I recommend using grid paper or turning your notebook paper sideways. That way we have nice columns to help us keep our information straight. It's going to help us to be reminded of our steps of division. Does McDonald's sell cheeseburgers? And you may have learned, does McDonald's sell cheeseburgers rare, where you have a remainder, and that's fine. For 5th grade, we do still have a remainder. We deal with the remainder. We interpret remainders. Beginning in 6th grade, we actually do something with the remainder, so we no longer have a remainder in 6th grade. And we'll look at both throughout this year. But for now, our main ones, does McDonald's sell cheeseburgers? And this, of course, means divide, multiply, subtract, check our answer to make sure that it's less than our divisor, and then bring down. All right, so let's see what that looks like. First, I have 3. How many 9s are in 3? There are 0 9s in 3, so then I can move on. 37. How many 9s are in 37? 9 times 4 is 36. So then I divided first of all. Now I multiply. 4 times 9 is 36. Then I subtract. It gives me 1. I check. Is 1 less than 9? Yes, it is. I'm good to move on. Bring down. So I bring down my next number, and then I just start the process over. How many 9s are in 18? There are 2 9s in 18, so I divided. Now I multiply. 2 times 9 is 18. Then I subtract. Check, is 0 less than 9? Yes, it is. There's nothing left to bring down. I don't have a remainder, so I have an answer. My answer, of course, is 42. All right, let's look at another example. I have 1,578 divided by 6. How many 6s are in 1? So right now I'm dividing. There are 0. How many 6s are in 15? There are 2 6s in 15. I multiply. 2 times 6 is 12. Next I subtract. 15 minus 12 is 3. I check. Is 3 less than 6? It is, so I'm ready to go. Bring down. And I'm ready to start the process again. So I divide. How many 6s are in 37? there are 6. 6 times 6, I'm multiplying. 6 times 6 is 36. Subtract, and then I check. Is 1 less than 6? Yes, it is. Then I can bring down. How many 6s are in 18? There are 3. 6 times 3, or 3 times 6, is 18. Subtract, and then I check. Is 0 less than 6? Yes. Is there anything left to bring down? There is not. So now I have an answer. 263 is my answer. All right, I can also explore division using base 10 blocks. So going back to the very first problem that we looked at, which was 12 divided by 3, or how many groups of 3 can I make from 12, or how many groups of 3 are there in 12? And so here I have 10 and my 2 ones, so that's 12. And what I want to do is I want to make groups of 3 and see how many groups of 3 I can make. All right, and I'm left with one over here. So I have 1, 2, 3, 4 groups of 3. So my answer, 12 divided by 3, again, is 4. And I can see that using base 10 blocks. So another way that we could actually look at 12 divided by 3 without separating it into groups, because what if I had really big numbers? Then it would make that really difficult. So instead, what I can do is I can go ahead and try to make this into an area model. If I can make one side of my base 10 model be 3 if I arrange everything into an array, if I make one side 3, then the other side has to be what my answer is. So let me go ahead and try to do that. So if I can make a side length of 3, all right, so I have a side length of 3. Let me just continue arranging everything into an array. All right, so now that I have a side length of 3, then the other side has to be what my answer is. And so I have 1, 2, 3 going one direction. So then whatever I have on the other side is going to be my answer. And in fact, that's 1, 2, 3, 4. So then my 12 divided by 3 is going to equal 4. Well, that's going to help us out quite a bit, especially when we have bigger numbers that I can't just make a whole bunch of little groups very easily. For example, if I had 379 divided by 12, it's kind of difficult to just make that into 12 groups. I could, it just takes a little bit more time. So maybe there's a better way. So instead what I can do is I can go ahead and place my 379. And if I can arrange these so that way I have one side length that is equal to 12, then my other side length should give me my answer. And so in order to do this, I'm going to go ahead and just recolor my hundreds so that way I don't lose those. And then if I have to exchange them, then that's fine. But I'm going to go ahead and group those together. Now, I don't have a side length of 12. I have a side length of 10. So how could I make a side length of 12? Oh, I know. I can just add 2 of these on here. Now I have a side length of 12. Well, let me continue doing that until I make an array. All right, so now I've done that. I've made an array, but I still have 19 more pieces left. So what I need to do here is try to make those into an array or part of the array. All right, I've successfully done that. And so, as I know this is now 12, I don't have 12 left. So I cannot put this as part of my array. It just doesn't fit. Because remember, an array has to be, the objects have to be arranged into a square or a rectangle, and so I don't quite have that. But I do know that I have a side length of 12, so I have part of it. And then 12 times whatever all of this is going to give me my answer. Well, I have 10, 20, 30, 31, right? Because that's 10 plus 10 plus 10 plus 1. So 10, 20, 31. And I do have a remainder of 1, 2, 3, 4, 5, 6, 7. So 31, remainder 7. And so that's by using my base 10 blocks. in order to find an answer. Let's go ahead and do another example and just make sure that we can solidify our learning here. Alright, so here I have 154 divided by 11. So I'm going to go ahead and place down my blocks. Alright, so I've done that. Now what I need to do is I need to make a side length be 11. So if I can make a side length be 11, then I know that the other side length is going to give me my answer. So what I need to do is build this into an array. Alright, so there we go. And now I have a side length of 11. If I can make the rest into an array, then that will give me my answer. Alright, so a perfect array. Now let's go ahead and count to see what our answer is. So I have 10, 11, 12, 13, 14. So then that means that my answer is going to be 14. And of course, always with division, we can multiply to check. 11 times 14, or 14 times 11. And let's check to see if we get our answer. So 1 times 4 is 4. 1 times 1 is 1. Tick, tack, 0. 1 times 4 is 4, 1 times 1 is 1. Add up my partial products, and then 154. I'm where I needed to be, so that is a correct answer.